Hey guys, welcome to another video. This is Unit 2 FRQ, Part 2, still about differentiation. So in this question, the graphs of the function f and its derivative f prime are shown above for -1, x, 4. So x is between -1 and 4. First question, find the average rate of change of f over the interval x between -1 to 4. Let's stop over here. Let's do it immediately. So I know that the average rate of change for any function, it is going to be f of 4 in this case, minus f of -1 over 4 minus -1. So what is f of 4 over here? F of 4 is basically equal to 1, and then f of -1 is going to be equal to -2. So it's going to be 1 minus -2 over 4 plus 1, which is going to be 3 over 5. Now let's continue. For how many values of x in the interval x between -1 to 4 does the instantaneous rate of change of f equal to the average rate of change of f over that interval? Okay, so this is a very interesting question. So first of all, the average rate of change is the same as joining the secant line between these 2 points from -1 to 4. They're telling me how many points do I have on this function where the instantaneous rate of change is the same as this average rate of change. Now, this is a positive slope, right? And I know that the instantaneous rate of change for this side over here is going to be positive because it's going up, which is also the same for this piece, right? So that being said, if we zoom in over here on f, at some point on the top over here, the tangent is going to be parallel to the average rate of change. It's not very obvious. Maybe if I do it like, so the tangent is going to be parallel at some point over here. So this means at some point, the instantaneous rate of change will be equal to the average rate of change, which is 3 over 5. Similarly, somewhere over here, because it's going to go up, this instantaneous rate of change is also going to be 3 over 5. So long story short, and I hate making long story shorts in calculus, if 2 parts of the functions are going up, this means that most likely the slope of the average rate of change for anything positive is going to be equal to a point on the curve when it's going up. So what I mean is the average rate of change is positive, so that means I want you to look only on the parts where the function is going up, because that will produce our positive slope. Meanwhile, if our average rate of change was negative, we would have only looked at these pieces over here and check, is there any point where x could possibly be producing a tangent parallel to the average rate of change? Okay, so to answer this question, basically, yes, there are 2 points. 2 values of x's where the average rate of change is equal to the instantaneous rate of change. So how many values? There are 2 values where the IROC is the same as AROC, according to the graph, of course. Part B. Write an equation for the line tangent for the graph of f at x is equal to 1. Okay, let's do it. So, at x is equal to 1, the equation of the tangent is going to be y minus f of 1, or y of 1, I like to call it y of 1, equals f prime of 1, x minus 1. So what is y of 1 or f of 1? It's basically 2, according to the graph. So y minus 2 equals, what is f prime of 1? So f prime of 1, it's going to be minus 2. So it will be minus 2x minus 1. Usually you can keep the equation like this. However, I love to put my tangents in the form of mx plus b. So it will be minus 2x plus 2 plus 2, which will be minus 2x plus 4. So the equation will be minus 2x plus 4. Let's look at it just for a second to confirm. Minus 2x plus 2 plus 2, yes. Mx plus b. Now, part C. In part C, they said for each, limit as x tends to 2, f of x minus f of 2 over x minus 2, and limit as x tends to 3, f of x minus f of 3 over x minus 3. Find the value or give a reason why it does not exist. So, according to the definition of a limit, f prime of 2 is actually equal to limit as x tends to 2, f of x minus f of 2 over x minus 2. So I'm just going to look at the graph over here. Where is f prime? Here. So f prime of 2 is basically equal to 1. So it does have a value. Now, I know what you're thinking. You're probably going to tell me, but wait, isn't this a sharp turn? Which means that this point is not differentiable? Well, yeah, that's true. See, just because f prime is not differentiable at x is equal to 2, this means that f double prime does not exist at that point. But this doesn't mean that f prime does not have a value, because over here we're treating f prime as if it's f, okay? Not like the characteristics of f. We're treating it the same as if we're finding like the coordinates. That's it. So f prime of 2 is basically equal to 1. Simple as that. Okay? So f prime of 2 is equal to 1. Now we're going to do the same thing for f prime of 3. It is equal to limit as x tends to 3, f of x minus f of 3 over x minus 3. So now if we're looking at x is equal to 3, we're looking at a jump discontinuity over here. So over here it does not exist because there's literally no derivative. It's not even there. Like it's a white dot, there's no value. So f prime of 3 does not exist because there is a jump discontinuity. Final question. Let g be the function defined by g of x is equal to e power of x times f of x, g prime of 0. Conventional product rule question. So g prime of x, it's going to be of the form of u prime v plus uv prime, where u is my e to the power of x and v is f of x. So g prime of x, once again, u prime, which is the derivative of e to the power of x, it's going to be e to the power of x. V is going to be f of x plus e to the power of x, f prime of x. Now plug in the number, we want 0, so g prime of 0. It's going to be e to the power of 0, f of 0, plus e to the power of 0, f prime of 0. E to the power of 0 is 1. What is f of 0? It is basically equal to 3. Plus e to the power of 0 once again is 1. F prime of 0 is basically equal to 1. So 1 times 3 is going to be 3 plus 1, which is 4. Hardest question in the worksheet, right? Thank you guys for watching. If you have any questions, please write it in the comments, and thank you for watching.